All right, guys, so we're back from that interruption again. And as you notice that our graph has disappeared, so we'll have to move to the next slide to get an idea of what we were doing, all right? So here on this graph, I'm going to use this one instead. So here is the same curve, but remember now, our X value for the first graph, because we are using the graph 2x squared minus x minus 6. That's the graph we plot. So we get the values of the x-axis. So wherever it cuts the x-axis. So here it cuts x-axis at negative 1.5 and x equal to positive 2. All right. So for the next value, now we need to look at, we put, remember when we did our calculation, we get y now to be equal to negative 2. We draw that line across, and then now we look at where that value would have cut the x-axis. And so we have negative 1.8 and x equal positive 1.69. All right, the next value, which is the third value that we were just looking at before we were interrupted. So here we draw our horizontal line at x equal 3 on the y-axis. And then we look at the x values here. So the x values here, you would read, if you read the x values here, you should get x equal to approximately negative 1.8, and then now the other value would be approximately 2.5. All right. So that would give you the answers to the graph. All right. Any question, guys? So I hope everybody is understanding what we're doing. So for this value here, we're looking at where this cuts the x-axis down here. And this one where it cuts the x-axis down here. And so this is approximately negative 1.8. So here x is approximately negative 1.8. Almost 2. And on the right side, it's approximately 2. X would be approximately 2.3, somewhere there. All right. And that's how we get the values, guys. Any question? Any question, guys? All right. So moving along then. All right, now intersecting graph. Now intersecting graph is another way that we can use to solve quadratic curve. Now what will happen is that we will get two graphs. At least we'll get one equation, but we'll break it up into 2 parts, right? Now how do we break it? Now this is our equation here, which is 2x squared minus 3x minus 2. Now to break this graph into 2 parts, we generally take off the part with the square as 1 part. So we make y equal to 2x squared. So that we would have as one equation. Now the remaining parts, we now want to break it up into another, we want to put that into another form. So if we bring the negative 3 and the negative 3 and negative 3x and negative 2 on the other side of the equation, then now we would have the other side, which is this side. And so here we have 2 parts. So what we are going to do, we're going to plot each part separately. So we're going to do one table for the 2x squared and one table for x plus 2. Now, remember now, this part would give you a straight line graph because the power of x is 1. This part would give you a curve because the power of x is 2. All right, so with that in mind, we now would plot these two on, we would actually calculate the values based on these two calculations. So we calculate values for 2x squared, and then we calculate 3 values for 3x plus 2. Anybody can tell me why we just only calculate 3 values for the 3x plus 2? Anybody?
Sir, because we only need what you call the end point and the beginning point and where it would cut the not sure should I axis, sir.
Y-axis. So for a straight line, we only need 3 points. So the 2 endpoints and where it cuts the y-axis. And it is easy to tell where it cuts the y-axis by looking at the equation, because it cuts the y-axis at the number 2. Whatever this number, so the number, the constant, that's where it cuts the y-axis. All right, so that is not difficult, guys. All right, is that clear? All right, so what we are going to do is to plot these two sets of values on the same graph. And so we're going to get a curve for one and a straight line for the other. All right, now I'm not going to go through the process of using this graph. I'm just going to skip to the animated graph that is already there. So you would have one curve looking like that, which is the 2x squared. And the other part, you would have a straight line looking like that. Everybody see that? Now, in this case, anybody have any idea how we would solve this equation? Can anybody guess? All we need to do is to look at the x values at the point at where the curve and the line intersect. So it means then the curve and the line intersects at this point, and it also intersects at this point. So all we need to do is read from the x-axis what the value of x is. So if you come all the way down, you'll see that x is equal to 2 right here. And for this one, x would be equal to approximately 0.5, negative 0.5. And so that's how we use that graph to solve. All right, so the same quadratic curve or the quadratic graph, you can break it up into 2 parts, the x squared parts, the straight line parts, plot the 2 of them on the same graph, look for where they intersect, read off your x values, and that's how you get the values for x. So we're solving the graph by finding the values for x. Any question, guys? All right. All right, so with that said, now moving on. So what we are going to be looking at now is graph of simultaneous equations. Simultaneous equations are 2 separate equations, and in this case, there are 2 straight line equations. So we don't have any x squared in it. So here, if we're going to solve the simultaneous equation, we plot both of these equations on the same graph. So we rearrange them so that y is the subject for both sides. Then we do our table. And then we calculate for y equal to x plus 2. So all of those values. And because it is a straight line graph, we only need 3 points. So we don't need to have a big table. So for y equal to 20 minus x over 3, these are the values here. So we're going to plot each of these. So we're going to plot x equal negative 3 with 4, x equal 0 with 2, then x equal 3 with 8. Then we go back again. X equal negative 3 with 7.7, x equal 0 with 6.7, x equal 3 with 5.7. We plot those two sets of values on the same graph. And again, I'm not going to work with this graph in the interest of time. So here we would have one line there and another line there. And all you have to do to solve the simultaneous equation is to look for where the two lines intersect. Now, remember, for simultaneous equation, you're solving for x and you're solving for y. So it means that to solve for the x value, you draw a vertical line from the point of intersection, and wherever it cuts the x-axis, you read that value. For the y value, you draw a horizontal line and meet the y-axis, and wherever it cuts the y-axis, you take y to be that value. So that's how we use this graph to solve for x and y. All right, so from here, x would be 2, and for here, y would be 6. Any question, guys? Everybody following so far? So it's a pretty straightforward process. All right, here's another simultaneous equation. So we have, in the same way, we would have plot these two graphs by making y the subject. All right, so y the subject from the second graph will give you, you divide both sides by 3. So 3 cancel on the left. So on the right, you get 2x plus 14 over 3. So that's for equation 2. Now for equation 1, you don't have to do anything to equation 1 because y is already the subject. So all you need to do now is to do the table, and these would be the values of the table. And then now if we do our graph, we will get our curve looking like this, guys. And in a similar way, we look at now where you would have the curve intersect, the line intersect with the curve. All right, guys, and then now you read your x values down here, and then your y values across. Any question? Any question, guys? All right. So we kind of move a little bit quickly today. So we only have about 50, a little bit more than 15 minutes to go. Now, what I will do, I'm going to allow you to start the graph the exercise that you would have screenshot earlier with the tables, and you were asked to do those graphs. So I'm going to end class here now, and you can start doing those graphs with the rest of the time. Is that clear, guys?
Yes, sir.
All right.
Yes, sir.
Okay. So we're going to stop here.